So in today's lecture, okay, we're gonna cover on chapter number topic number 6, okay, in your syllabus, which focus mainly on the sampling distribution. Okay, so why sample the population? So as okay, what I introduced earlier this semester and also just now, okay, to use the whole population for you to study will be time consuming. Okay, and then also the cost involved, because when you want to cover every item for every individual in the population, it will be not just time consuming but also very costly. Okay, and then almost very impossible. So because certain individuals, certain items are located in an area that you may not be able to access. Okay, so and then also when you collect, when you cover too many items in your study, okay, you might end up destroying or having defects in your in the data that you collect, okay, because of the time taken and the cost. I mean, especially when it's taking too long, so some of the information may become obsolete or invalid. Okay, so and the main thing is whenever we do study, the sample results are actually sufficient or adequate, okay, to be used to make your conclusion, okay, about the population. So that is something that, so for example, I think like a few days ago or yesterday, okay, we have like a simple survey by Merdeka Center, okay, showing how uh, the based on the study by, I'm not sure how many sample, but I think it's around 2,000 plus individual given the questions to ask about the performance of the current Prime Minister Muhyiddin Yassin. Okay, so basically based on that 2,000 plus samples or individual, they come up with a conclusion about for the whole country. So you may agree or disagree with the finding, but that is the nature of doing research. People based on sample. Okay, so and then next is what is probability sampling? Okay, a probability sample is a sample selected that each item has a known likelihood, okay, of being included. So in chapter number 3, when you learn on the topic of probability, okay, oh sorry, chapter number uh, 4, okay, especially on the binomial and Poisson distribution, okay, you construct. Before that, you learn on this frequency, this probability distribution of tossing a coin 3 times. What is the probability of getting a hit? Okay, when you toss the coin 3 times. So basically, when you want to do a research, okay, each item in the population, okay, so you know what is the likelihood or the probability of being selected in the sample. Okay, so of course, this is just in terms of the idea, because if you do a research, okay, and then let's say you want to collect certain number of uh, persons or individual from the population, so you know what will be the probability of each of the item to be selected to be part of the sample. Okay, so of course there are many techniques for people to, whenever you do research, okay, to collect your sample. Okay, and this, bear in mind, this is based on what we usually term as primary data analysis. Primary means the data is collected based on survey or questionnaire. Okay, whether face-to-face questionnaire basis, if you go and ask people at, you go and meet the people, or you send questionnaires via online survey, okay, Survey Monkey, Google Form and whatnot. Okay, because now during COVID-19, the preferred method of data collection will be on using online method. Okay, but sometimes you need also to interview the people face to face in order to collect the information. So whenever you want to collect primary data, okay, data that is based on survey, okay, there are several methods. Okay, these are the most common one: simple random sampling, systematic, stratified, okay, cluster sampling. So of course, we're not going to discuss this in detail for economic students. Okay, so I believe every one of you is taking, belong to the Bachelor of Economics or Bachelor of Agribusiness. So you will take maybe in your 6th semester or your 7th semester the research paper method, okay, kertas ilmiah, where you will do a simple project, okay, and depending on your topic. So some topic might require you to collect data via survey. So you might, the easiest one will be the simple random sampling, meaning you don't follow any specific technique, okay. But if you go for systematic, stratified, or cluster sampling, so you need to follow some procedure. Okay, so we will not discuss this. If you want to know more, you can Google this term in the internet and you can just find some example. Okay, what this each of these method, okay, refers to. Okay, but the easiest one will be simple random sample, meaning, for example, if you want to, let's say you want to collect 100 students, sample from 100 UM students. So basically, you just send the email to everyone. Let's say you set a system where the email can be sent to all the students from UM, and those who actually reply, the first 100, you will take that as your sample. So let's say you want 100, but maybe you send the questionnaire, let's say to 1,000 students, okay? So the first 100 students, you end up taking the data to make up your sample. So meaning there is no preferred, there is no specific technique for you to choose your sample, okay? So that is the easiest one lah. Okay, and again, the rest we will not discuss in detail. You will learn this more in your semester 7. Okay, and then the one of the most important part whenever you deal with sampling data. Okay, when you use sample data instead of population data. Okay, so let's say you want to do a study on the UM students. So there are 20,000 UM students, 20,000 plus UM students. So let's say from the 20,000, you want to select, let's say, around 200 students to be your sample. This 200 students is supposed to represent 20,000 students. Okay, so this 200, okay, you can collect using any of this method: simple, systematic, stratified, or cluster sampling. Okay, so let's say you collect using simple random sample. Okay, you send the Google form or to in the mailing list of all UM students. Okay, and then you hope for some of them to respond or answer your survey questions. Okay, and then at the end of the data collection, okay, you will analyze your data. Okay, so of course, in the beginning of the slide, okay, when we refer why we do not collect data from population, okay, because of the time, okay, the cost involved. So if you were, let's say, to collect every information from the UM student, let's say that 20,000 students, you will get okay, if you refer to the previous chapter, okay, whenever you want to calculate the probability, okay, so the value of the mean here, the mu, okay, the mu refers to the population mean, and then the value of the standard deviation refers to the population standard deviation. How to calculate these two, you already learned in the previous chapter, okay, using the formula, or whether you use online calculator or manual formula. So you already learned what is mean, what is standard deviation, and how to calculate them. Okay, but when you rely on sample, okay, your information, of course, let's say from the 200 students that you collect to represent that 20,000 students, you cannot expect that the value of the mean from the 200 students, okay, so this mean, okay, this mean of 200 X bar, which is the mean, the sample mean, okay, this belongs to the 200 students that you collect the information from survey, okay, whereby this mu will be the mean of the 20,000 UUM students, okay, meaning if let's say you want to calculate how much what is the mean of the spending, okay? Perbelanjaan, the average spending per month on food. Okay, so let's say on average UUM students spend around um, 300 ringgit. Okay, it might be low, it might be high. Okay, but I just put one number here. So let's say on average UUM students spend 300 ringgit on food alone. Okay, meaning on average 10 ringgit per day. Okay, 10 ringgit per day on food. So 30 days, 300 ringgit. Okay, so some might spend more than this, but okay, just for the example purpose. So let's say the mean of all the 20,000 students. So let's say if you were to ask everyone, okay, so let's say there is a directive or instruction from the vice chancellor that every student, registered student in UAM, must answer the survey question in your portal. Okay, so you will, and then from that information, we know that the 20,000 students spend on average, the mean will be 300 ringgit per month on food. Okay, but if you were to rely on the 200 students only from the sample, okay, you may get 300, or in reality, you will not be, the value of X bar will not be exactly equal to the value of mean. So let's say you might end up getting the X bar or the mean on the average spending on food from these 200 students. Let's say you will get 310, 310, meaning 310 ringgit. Okay, so that is the average spending on food using data from the 200 students. Okay, so 310 minus 300, we get $10, okay, or 10 ringgit. So that 10 ringgit refers to what we call as the sampling error, the difference between the sample value and also the population value. So this $10 is on the sampling error of the mean. Okay, and then you can also get the sampling error of the standard deviation, sampling error of the variance, and sampling error of the proportion. Okay, this proportion here you will learn later in chapter 8 and 9. Okay, but on chapter number 6, okay, so we only focus on the first three first. Okay, X bar, standard deviation, and variance. On the proportion, okay, you will cover in the next topic. Okay, so the reality is whenever you do a survey or a study based on sample data, okay, the idea or the objective of the sampling, okay, because as what we discussed before, there are several methods to collect your data, whether simple, systematic, stratified, cluster, or you can, and there are other methods that is not mentioned here. Okay, but why you follow, why you need to follow the guidelines, the steps, so that whenever you collect your data, okay, is one of the reason is to minimize the sampling error, because you want this value X bar to be as closest as possible to the value of the population mean. The same goes to the standard deviation of the sample to be the same or the close possible. So you want to minimize the difference value here. Okay, so the bigger the value or the bigger the sampling error, the less accurate or the less reliable is your sample information. Okay, and then the information or the conclusion that you get from your sample data may not be reliable, because when you do a survey based on sample, okay, you want your sample data to be representative, okay, boleh mencerminkan the population characteristics. Okay, so for example, on that 200 students, we collect data to get how much they spend on food per month. Okay, so let's say from these 200 students, okay, most of them consist of, let's say, students who are very rich students, students who bring cars to the university. Okay, they spend, let's say, not 300 ringgit, let's say they spend on average 30 ringgit per day. Okay, 30 ringgit per day means on monthly, on average, it could be 900 ringgit, okay, on food. So 30 means that, okay, they go and buy, you know, uh, maybe some other days they spend less, some other days they spend more. Maybe they love to eat outside on fast food restaurant. Okay, and buy all these tea life or any other junk foods, or stuff that will cost more, that will add up to the monthly expenditure on the food. Okay, so if the sample uh, does not cover student from different backgrounds, but focusing mainly the students covers higher income group students, so your information from these 200 may not reflect the value of the population mean. Okay, so that's why it is important that whenever you collect data, okay, is one of the uh, criteria of a good sample is that the sampling error is minimized or lowest. Okay, so that it is reliable, it can represent the population value. Okay. So next is, okay, again, just another term here, sampling distribution of the sample mean. Okay, is the probability of consisting all possible sample means. So, okay, this definition you can see from this example here. Okay, so here you have 7 employees. Okay, so assuming these 7 workers represent the population, meaning in this company there are total of 7 workers. Okay, so this is the average hourly earnings, meaning how much they earn per hour. Okay, so that is the information from the 7 workers. So what is the population mean? You can see here using the formula summation x over n, the population mean for the 7 workers will be 7.71. Okay, but then if you were to choose 2 people, okay, from these 7 workers, okay, meaning 7 will be the population data. So you want to take a sample of 2 workers to get what will be the mean value of the income. The hourly age rate, the mean of the hourly earnings. Okay, so if you want to take 2, so there can be many combinations. You can take Joe and Sam, Joe and Sue, Joe and Bob, and or any other combinations. So you can use this formula n choose n. So meaning there will be 21 different combinations possible. Okay, and meaning that if you want to take a sample of 2 people, okay, you may end up one of these 21 possible combination. Okay, so for example, you may get Joe and Sam as your sample, or you may get Sam and Sue, or any other combination from this possible 21. Okay, so if you were to take Joe and Sam, the mean will be 7. If you take, for example, Art and Ted, it will be 8.5. Okay, so this definition here, the sampling distribution of the sample mean is the probability of consisting all possible sample means. So this definition reflects this one. Okay, consisting all the possible mean from the combination of the sample that you can get. Okay, so from the population of 7 people, there will be 21 different combinations possible. Okay, so and then each of the combination you can calculate what is the mean of the pairing. Okay, for each of these. Okay, and then if you put in a sampling distribution table, okay, the mean of 7 appear 3 times. For example, here 7 appears 1, 2, and 1, 2, and 3 times. Okay, $7.5 appear 1, 2, 3, 4, 5. Okay, you can see here. Okay, so $7 appear 3 times, $7.5 appear 9 times. Okay, until you finish all the different combination. Okay, how many times it appear. Okay, and then you can construct what is the probability of choosing a sample mean of 7, which is 0.1429. So how do you get 0.1429? Simply by dividing 3 divided by 21. Okay, so 3 divided by 21, you should get, okay, inilah 3 divided by 21, it should be 0.1429. And the rest follows 9 over 21, 6 over 21, and 3 over 21. So you can see here, this is the probability, for example, 0.1429 or around 14%. Okay, 14% is the probability of choosing the combination of mean $7, okay, from the, okay, of getting a mean of 7, okay, from the 2% that you can get, or it could be 42%, okay, of getting from the sample of 2 workers, whereby the mean will be $7.5. So you can see that the probability of getting 7.5 is the highest lah, okay, compared to 7 and 8.5. Okay, and when you plot this thing, okay, usually you will get a normal distribution. Okay, so when you construct the sample mean, the probability from the sample distribution, okay, 0.1429, okay, what is the frequency, I mean what is and then 0.4285, okay, so you can see here distribution of the sample mean versus the population distribution. So if you were to plot from the population data, okay, the shape may not look like a normal distribution, but from the sample mean itself, from the distribution of the sample mean, the one that you get from here, okay, you can see that it goes up and then it goes down again, which is something that you see here. Okay, $7, 0.13 just now, okay, and follows to the rest. Okay, and you can see that the shape, okay, resemble a normal distribution. Okay, so the idea of sampling distribution is to, okay, the spread of the mean is less than the spread of the, so you can see when you take sample, okay, so the idea is that is to represent, or the distribution from the sample will refer to the, I mean, will represent more like a normal distribution. Okay, and the idea of increasing the sample size. Okay, so this is what usually, of course, okay, in the beginning of the slide just now, okay, we learned that, okay, why we cannot take sample our population, because it is time consuming and also very costly. So let's say in our example just now, we only take 200 students, okay, 200 students from the possible 20,000 UUM students, okay, to do our survey. So let's say from 200 students, we increase the sample size to, let's say, 400 students. Okay, from 200, we increase to 400. Okay, so by increasing the sample size, the spread of the distribution becomes smaller. So what does it mean by the spread of the distribution? Okay, recall that in the previous chapter, you learned on this, the shape of the normal distribution. It can be steep, it can be flat, okay? So the higher, or the higher your sample size, your standard deviation or the spread of the distribution will become smaller, which means, okay, so this shape could be for 200 samples, okay, but it might look like this, okay, for 400 samples. So the blue will be for 400, okay, sample size. The red would be for 200 sample size, meaning that the higher your sample collected, okay, the spread of your distribution will become smaller. In other words, the standard deviation, okay, or the variance from the data will become smaller and smaller, because you are getting closer to the population information. Okay, the higher the more data you collect, the better it is. Okay, but of course you need to you need to you need to uh, you need to check how much time you have, how much cost involved. Okay, because that's why in whenever you do study, you cannot always go for the, simply choose, whatever number of sample size that you want. You need to weigh in, okay, how much time, how much cost that you have, okay, in order to for the number of sample size that you want to collect. Okay, okay, so that is one of the few things lah that you can information that you can obtain whenever you rely on sample. Okay, of course, this concept of sampling you will understand better, okay, when you do your own study, your own simple research. Okay, maybe in any of your assignment before you reach semester 7, but you will learn more when you okay, when you take the subject of research method. Usually you will take that subject in semester 6. Then in semester 7, you will use that knowledge that you get from research method paper to do the research paper subject kertas ilmiah in your semester 7. Okay, so what you learn in this subject this semester on the mean, variance, how to calculate all those things, okay, how to do, okay, in fact, when you learn on this ANOVA and hypothesis testing, so this will be very relevant when you learn research method paper and also on the kertas ilmiah, the research paper that you will take in semester 7. Also in your basic econometric subject, okay, you will look again at this concept of hypothesis testing. Okay, so you will draw conclusion from the output that you get from the regression output and how you come up with the decision, okay, from the hypothesis, from the result that you get. Okay, so again, it is also related to many subjects, okay, not just in your research paper subject. Okay, so that is on the concept of sampling. So why we go for sample, okay, and then how to construct sampling distribution, okay, and then it brings us to this concept of CLT, okay, central limit theorem. Okay, if this concept is very related to point number C just now, okay, if the bigger the sample size, okay, the spread of the distribution becomes smaller. Okay, in other words, uh, you are approaching the true value of the population, because 200 sample versus 400, of course 400 is better than 200 because you get more information from 400 compared to 200. Okay, and 400 versus 800 samples, of course 800 is better than 400 because you get more information from 800 versus 400. Okay, and the list goes on lah. So the idea of the CLT, okay, refers to the the concept of sampling, how much sample size. Okay, so if all samples of particular size are selected from any population, the sampling distribution, okay, recall, okay, what is sampling distribution? This one lah, okay, the sampling distribution, okay, of the sample mean is approximately a normal distribution. So this part is what you see from this one here. The sampling distribution is approximately normal. When you plot the sampling distribution from the sample that you collect, the shape of the distribution from the sample will the shape of this will be close to a normal distribution. Okay, is approximately normal. It's not exactly normal, but approximately normal. Okay, this approximation improve with larger sample size. Okay, means that, okay, if you recall from the previous point, okay, if you have lower sample size versus higher sample size, 200 sample versus 400 sample size. So the blue will be 400, the red will be 200 sample. So the higher the number of sample that you take in your study, okay, first the shape of the distribution will become much steeper, okay, or in other words, the spread of the distribution becomes smaller, the variance becomes smaller, and and then it of course the shape is normal distribution, okay, and then uh, this blue shape is better than the red shape because first the variance becomes smaller, and okay, and then in terms of the accuracy of the estimation, okay, this approximation to normal, okay, improve with larger sample size, meaning the higher sample size that you have, the shape of the distribution becomes more and more normal. Okay, it refers more like a bell-shaped distribution that you learn from in terms of theory in chapter 5 before last week. Okay, we learned that the bell-shaped distribution, okay, in order to get a bell-shaped distribution, you need a bigger sample size. Okay, so the bigger the sample size is, the shape of the distribution becomes more like a bell-shaped distribution, the one that you learned last week. Okay, here also you can see the one that you learned from last week. Okay, different sigma versus bigger sigma. Okay, small sigma 3.1 the shape of the distribution become flatter versus when the sigma is bigger, okay, it's much flatter. So the idea is when you increase sample size, okay, from 200 to 400, for example, the sigma becomes smaller. Okay, so 5.0, I mean the one in blue, okay, would be similar to a 200 sample size standard deviation. Okay, but then if you increase to 400 sample size, okay, you expect that the shape of the distribution to become much steeper. Okay, and then the spread of your data becomes smaller, which is measured by your standard deviation. Okay, so this is the main idea of CLT, or central limit theorem. Okay, and then usually the idea is that uh, the sample size required, okay, the minimum sample size required will be 30 or more, okay, for the distribution to become normal. Okay, um, okay, of course, as small as 10, okay, you may get you may start to get the shape of the distribution to be something like a normal distribution, okay, or a bell-shaped distribution, but it may not be a perfect bell shape, okay, or a good or a nice looking bell-shaped distribution. Okay, but if your and then if the distribution is skewed, okay, you learn on this skewness in earlier chapters. It can be positively skewed or negatively skewed, okay, distribution. Okay, so if your distribution is skewed, then higher sample size, or at least 30, will make the shape of the distribution becomes normal. For example, if your distribution is positively skewed, okay, in order to make positively skewed becomes normal distribution, you need to increase the sample size. Okay, the same goes as negatively skewed distribution. Okay, so if it is negatively skewed, you need a bigger sample size, at least 30. Okay, meaning that the number of sample or respondents or the individual that you want to interview from your survey must be at least 30. Okay, so that if your distribution originally is skewed, whether positive or negative, okay, the main idea is that you want your distribution to be normal. Why is it important to have a normal distribution? Then you can make conclusion from your study. Okay, because if you want to calculate the probability as what you learned last week, okay, so that assumption must follow a normal distribution. Okay, and then finally it brings us to this concept of the mean of the sampling distribution is equal to mu, but the variance is equal to sigma squared over n. Okay, the mean is the same, okay, equals to mu, but now the variance becomes sigma squared over n. Okay, if you compare to the previous topic, okay, if you don't use sample, meaning you rely on population, the standard deviation is sigma, or in other words, the variance will be sigma squared. Okay, sigma is the standard deviation, so sigma squared will be the variance. Okay, but if you use sample, okay, but when you rely on sample, okay, under central limit theorem, okay, meaning that if your distribution becomes normal, okay, when you plot your distribution from the sample, okay, it becomes normal, then the variance from that distribution will be sigma squared over n. So what is the difference is that you need to divide by the number of sample size, meaning the variance now becomes sigma squared over n. So the meaning that the standard deviation will be sigma over square root of n. Okay, so this will be the standard deviation. Okay, variance will be sigma squared over n. So if you take square root of this thing, if you take the punca kuasa 2, square root of sigma squared over n, so the sigma squared, you cancel the square, so you get square here, n, you become square root of n. So the standard deviation will be sigma over square root of n, okay, under the central limit theorem. Okay, so in this slide, you can see that the changes in the shape of the distribution. So even though the population, if you plot the data from the whole population, for example, from UUM students, if you plot the amount of spending, okay, of all the students from student number 1 until the last student in registered active student in UAM, okay, you might get the shape of the distribution to be something like this, or meaning that it is not normal. Okay, but when you take sample from the original population, so let's say you take 200 sample to represent from that 20,000 students, okay, and then you can see that as you increase the sample size, okay, from as small as 2 until n equals to 30, okay, or even more than 30, okay, you can see that the shape of the distribution tends to be approximately normal. Okay, even though the original population plot, I mean the population from the original data is not normally distributed, but from the sampling distribution, you will convert, or you can have a normal distribution, whereby from once you have a normal distribution, then you can make inference, or you can make conclusion from the data that you have. Okay, so that is one of the reasons why you need a normal distribution, okay, in order for you to make conclusions, okay, from the data that you collect. Okay, so so this is just an example. You have a sample of 40 employees. Uh, so the population will be 40 employees. So then you can see that when you uh, collect a sample of 5. Okay, so what this shows actually, okay, so from this information here, okay, this company has 40 employees, okay, and then it decided to form a committee of 5. Meaning from this 40, they want to select 5 workers to be the representative of the company, okay, from the 40 people. So what you can see here, okay, uh, if you, so from the 40 employees, okay, if you take 25 sample of the 5 employees versus 25 sample of 20 employees, you can see that the shape of the distribution tends to be more normal than this one. So what it means is that if your if you increase, okay, from 5 to 20, okay, meaning that the sample size increase from 5, you increase to 20, okay, you can see that the shape of the distribution becomes normal, okay, compared to if you only take 5 sample from your data. Okay, so again, all of the things that you cover in the first 15 slides, okay, basically focus on the theoretical concept, meaning what is central limit theorem, what is sampling, why, how do you get a normal distribution from a sample, okay, and then the main part will be on the calculating the probability using sample data, okay, from a normal distribution. Okay, so we understand from the slide just now, okay, under central limit theorem, the variance will be sigma squared over n, or the standard deviation will be sigma over square root of n. Okay, and if I can recall, go back to this original slide from chapter number 6, from chapter 5, okay, last week. Whenever you want to calculate the z, okay, it will be x minus mu divided by standard deviation, okay, which is sigma. Because in the previous topic, we don't learn on the concept of sample yet. So whatever that you calculate from the topic last week are all based on population data. Okay, so if you compare this formula, the denominator is always the standard deviation. Okay, so we extend that the concept. Okay, but now instead of using population data, we use sample information, meaning the information that we collect is taken from the sample, not taken from the population. So that's why there are two things that change. First, the denominator, and second is your numerator, the symbol for the you can see here, instead of using x, now it becomes x bar. Okay, because Now we are relying on the sample mean, okay? Because when you take sample, you calculate what is the sample mean. And then from that, you want to convert into Z. But from the previous topic, because your data is based on population, there is no need to take sample mean. Okay, that's why the formula, or when you refer to the question, is all based on information from the population. So it just basically X is also referring the data from the population minus mu over standard deviation from the population as well. Okay, but when you rely on information taken from sample, okay, let's say from 200 students, okay, to represent the 20,000 UUM students. So in order to get the Z distribution, okay, you need to follow the information derived from sample, which is now the X must be converted, or you need to rely on the sample mean, and your standard deviation now become the standard deviation of the sample mean, okay, which is sigma over square root of n. So you need to be you need to be aware of the difference between the simple formula from population versus the formula of the Z distribution if the information is taken from sample. So now it will be x bar minus mu divided by square root sigma over square root of n. Okay, so and then another family under normal distribution is also what we call the student T distribution. Okay, if you check your textbook, okay, towards the end of the chapter, okay, you can see this table here, which is called the student T distribution. Okay, so basically it is also a family of normal distribution. So we don't call it the Z distribution, but we call it the T distribution. Okay, so of course you will learn this more in the next topic. Okay, but bear in mind the T distribution is also a family under this normal distribution. Okay, so but we're not going to focus on the T distribution on chapter number 6. Rather, we are only focusing on the Z first. The T distribution, x bar minus mu over sigma. Okay, you notice that the main difference between the Z and the T is the notation for the standard deviation. For the T, we only use S, meaning standard deviation from the sample. But for the Z, we are using the sigma. Okay, why the difference between the two? You can see on the top here, sigma is known. This one is sigma is unknown. Okay, what's the difference between sigma known and sigma unknown? Sigma known means assuming that we know what is the standard deviation of the population. Meaning, let's say from previous knowledge, from previous study, or from old study, from you know that we know for sure what is the standard deviation of the population. So let's say in the case of UUM, okay, although we want to take 200 sample, but let's say from previous study, or for some information, let's say the management informed that you can take 200 sample to do a study, but we know for sure what is the standard deviation for the 20,000 students. So rather than calculating the standard deviation from the 200 students, you can use the standard deviation from the population. Okay, meaning that if the information is known in advance, okay, from the population, so so this is what we call sigma known, meaning from the 200 sample, okay, recall that, okay, our example just now is 200 sample of UUM students. Okay, we want to know how much they spend on food, okay, how much they spend on food per month. So from these 200 students, okay, you can calculate the mean, okay, or X bar, the mean of the spending on food, okay. But if you want to calculate the standard deviation, you can also do that, okay, which will give you the S, the standard deviation from the sample of this 200, okay. But if for some reason, you have the information, what is the sigma from the from the 20,000 students. Okay, from the 20,000 students. So let's say there is an old research or previous study that involves the 20,000 students. So you can use this information because it is much better than using standard deviation from the sample. Okay, so if you know what is the standard deviation of the population, then use it. Okay, so under this assumption, if you know what is the standard deviation of the population, then you are going to use the Z distribution. Okay, but if you do not know what is the standard deviation of the population, then you need to use the standard deviation calculated from the sample itself. Of course, if you were to ask me, in the real world, uh, usually we do not know what is the standard deviation of the sample, of the population. Usually researchers will calculate the standard deviation from the sample, meaning from the 200 sample of students, okay, you can calculate what is the X bar, what is the mean, and also we can calculate what is the standard deviation, what is the standard deviation from the sample of 200 students. Okay, so you learned before how to calculate standard deviation from sample. Okay, if you have forgotten again, please check your notes from the previous slide. Okay, if you still recall from the formula, okay, the one that I showed you. Okay, you have the standard deviation calculator, correct, using population or sample. So if you were to use the sample formula, you need to divide by n-1. So that is the formula that, or the way to calculate standard deviation from sample data. So the same principle applies. If you want to calculate a sample standard deviation, okay, you need to follow the formula, the appropriate formula to calculate the sample standard deviation, meaning you need to divide by n-1 lah. That's what you did in the previous chapters. Okay, so of course, in this chapter, we are not going to focus on the T yet. Okay, the T distribution you will cover on chapter number 7 onwards. Okay, but chapter number 6, our focus is only on the Z distribution. So we're not going to cover on the student T yet. Okay, so that will be covered on the next topic. Okay, so the rest is the same, exactly the same, how to read the Z table or how to use the calculator that you used before, okay, in order to calculate the probability. Okay, so for example, find the Z value corresponding to the mean of 31.38. Okay, so so I think there is one slide missing, or you can find from the original book. Okay, you can go back to the main book here. Okay, this one. Okay, you can see that this information is provided here. Okay, what is the mean, the population mean, and what is the standard deviation. Okay, from on page 234. Okay, that gives you understanding on this example here. Okay, so basically to get the Z value, you follow the same procedure, X bar, but now it's not X, now it's X bar minus mu divide by sigma over square root of n. So if you go back to this, to the original, to the main textbook, okay, you can find this information here. Okay, where do you get the sigma and the sample size? Okay, so and then the rest is the same. Okay, you get the Z to be 1.8. Okay, so once you get 1.8, so the next step will be PZ greater than, find the Z value, and then you want to calculate what is the probability. Wait, is it more than? Okay, find the probability of Z greater than 1.8, correct? Okay, so you want the area to the right of the 1.8. Okay, so 1.8, and to the right of that, okay, will be the area here highlighted in. Okay, so your table only gives you the area in yellow here. Okay, so your table only gives you this part. Okay, so you need to deduct by 0.5 lah. So your table only gives you 0.4641, okay, based on 1.8. Okay, and then from there you can calculate what is the area on the right side of the table, or you can alternatively use the online calculator as well. Okay, the one that I use from this website as well on the Z-score calculator. Okay, so you can just put here 1.8. Okay, and then you should be able to get PZ more than 1.8 will be 0.0353. Okay, should be the same here lah, 0.0359 sama lah. Okay, so that will be the solution if you want to calculate, meaning that the way you read the table or the way you use your calculator will be the same. Okay, the only difference is that you need to divide the denominator by square root of n. Okay, sigma divided by square root of n. Okay, and then take note that now the notation from x has been changed to x bar. Okay, so okay, I do not want to discuss this example. Okay, I will go straight to the main textbook here. Okay, so again, I need you to do one simple exercise. Okay, on this chapter, which basically almost like 98 or 99% similar to what you did before in the previous one. Okay, so you have, okay, you can refer to question 31 for solutions, question 30, okay, question 31 for solutions. For example, here you can see, okay, if you compare the way the information is provided, okay, from this chapter compared to the previous chapter, okay, the one that you did last week, the main difference is the use of the word sample mean. Okay, the use of the word sample mean. You will see the word sample mean is used, okay, and also or the word mean, because now the formula has been changed to x bar. Okay, no longer x. Okay, so x bar is sample mean or mean lah. Okay, so you want to calculate the value of the mean model. Okay, if you recall, first you need to convert from x into z. Okay, in the previous chapter, but now you need to convert from x bar into z, meaning sample mean converting into z. Okay, so that's why you can see the word sample mean being used throughout the questions, whether in any of the questions that that uses sample, okay, you will see the term sample mean being used. Okay, sample mean, because now you are referring to x bar, no longer x lah. Okay, but the way to refer to the table is the same. Okay, the main difference is that now the formula is changed to x bar. Okay, now being changed to x bar minus mu, okay, divided by sigma over square root of n. So this is the main formula. Okay, so x bar is the sample mean. So let's say if you want more than 36 hours, so 36 will be x bar. So 36 minus the mu divided by standard deviation, but you need to divide by the square root of the sample size. So everything, those information will be provided in the question. Okay, so for example, question 31 here. Okay, so you can check the solutions at the back. Okay, we don't have time to do this now. Okay, okay, maybe we can do maybe one question here. So you can see here the mean is 35. Okay, or the mu. Okay, the mu is 35 and the sigma is 5.5, and the n sample size will be, so this is the n. The n is 25, the mu 35, the standard deviation is 5.5. What can you say the shape about the distribution of the sample mean? You can say that it is approximately normal. Okay, because that is what it is already mentioned here, follows a normal distribution. So it is normally distributed or approximately normal. Okay, what is the standard error? Okay, so standard error is calculated as sigma divided by square root of n. Okay, so that will be the standard error. Okay, sigma divided by n square root. Okay, so meaning that your sigma will be 5.5. So it will be 5.5. Okay, divided by square root of 25. Okay, which is 5 lah. Okay, so 5.5 bahagi dengan punca kuasa 25. 5.5 divided by square root of 25. You should get the answer for question B. Okay. What proportion of the samples will have mean useful life more than 36 hours? Okay. So for this one, okay, if you want to solve using the online calculator, okay, so you need to be careful whenever you use this one, because here it is not, there is no information or there is no formula for you to use the sample standard deviation, because here is always sigma here. Okay, so you need to calculate manually here, for example. Okay, in our question here, our standard error, okay, notice that we don't use the word standard deviation, we use the word standard error. Okay, because we are referring to the sample. Standard deviation refers to population, but whenever you refer to sample, whenever you calculate based on sample, we call it standard error, which is sigma over square root of n. Okay, so the standard error, which is obtained by 5.5 divided by square root of, sorry, I mean, if you use your scientific calculator, then I think it should be, okay, 5.5, okay, divide by divide by what? Okay, square root of 5 square root. Okay, betul ke? Okay. So you should get 2.45. Okay, 2.459. So let's say we take this value, okay, to be our standard deviation. Okay, then the rest you can just plug in as the same one. Okay, x now become x bar. Okay, so in this question here, okay, you want to be more than 36. Okay, so 36, so you can put here 36. Okay, your mean just now will be 35. Okay, so you can calculate. Okay, so now your z will be 0.45. So from here you can see already what are the possible solutions, whether it is less than or more than. So your question asks you to calculate more than 36. So more than 36 will be 0.34216. Okay, you can check the answer at the back for this question. Let's see whether we get the answer. So this will be chapter number berapa ni? Chapter 8. Okay. Okay, so chapter 8. Okay, chapter 8, question 31, correct? Okay, so I think this is the solution that we are referring to. Okay, A, what is the distribution? It will be normal. Okay, and you can see here, it will be 5.5 over, saya silap put, okay. Okay, oh, I got my standard error wrong just now. So 5.5 divided by square root of 25, it should be 1.1. Okay, and then from here, you want to calculate what will be the probability value. Okay, so now, I mean, I need to go back and change the value of the standard error. Okay, so this will be 1.1. Okay, so the one that you want to refer to is this one, more than, okay, which is 0.1816. Okay, betul lah, 0.18. This one supposed to be minus, okay, not plus. Okay, the book has some typo error here. Okay, so the answer is 0.1814, which is close to us lah, 0.1816. Okay, so you can refer to this one as well. Okay, but whenever you want to use this calculator, Okay, make sure that this value you need to calculate manually first, meaning sigma over square root of n. Okay, and then the rest you can just plug in from the information. Okay, because this standard deviation now, okay, is consists of sigma divided by n square root. Okay, so from this you get 1.1. So you plug in 1.1 here. Okay, and then the rest is the same. So this is 36 just now. This is 35. Okay, so you want this one more than, so it will be this one. Okay, so the rest of the questions from okay, from the book will be the same lah. Okay, so for your exercise, okay, so again, why you need to do the exercise? Okay, because it will help you again in your preparation for the upcoming test. Okay, so this chapter will cover for test number 3. Okay, if you check here, okay, test number 3 will cover chapter 6 and 7. Okay, so whatever that you learn from today, okay, on today's lecture, okay, will be applied, okay, useful for you to okay, to help you to answer the test number 3 lah. Okay, so for for exercise, for today's exercise, okay, I will put up the link in your OL, okay, and the submission will be by tomorrow afternoon. Okay, so only 2 questions, question number 32 and question number 34 from page 239, okay, in your textbook. Okay, so both questions are very much similar. Okay, so similar to the previous chapter, but now you have the concept of sample. Okay, so you need to divide. You need the formula now become x bar minus mu divided by the standard error. Okay, SE. Standard error is sigma over n square root. Okay, so that will be applied to both 34 and 32. Okay, so I think that's it for today. Okay, check your OL for the link for this exercise that you need to submit by tomorrow, and also the get ready for test number 2. Okay, topic 4 and 5. Okay, the date, okay, could be changed to Thursday. Okay, from 9 a.m. to 5 p.m. in the evening. So there will be 20 questions, multiple choice. Okay, 1 hour for you to finish, to complete answering the questions. Okay, so if there is any